We're going to take a look at multiplicity. So we look at a function that is already in factored form, and we know a couple things. The first thing I can see here is even without multiplying it out, I know I got a cube and I got a squared. I mean, you're welcome to multiply that out, but I know that when I multiply x plus 2 times x plus 2 times x plus 2, I'm going to get a polynomial of degree 3. And x minus 1 times x minus 1, I'm going to get a polynomial of degree 2. And then when I multiply those together, I'm going to get a polynomial of degree 5. So in order to find the degree, you just add up all the exponents of the, how many terms we have. So the degree is 5. All right. The other thing is I'm looking at leading coefficient, and this one we should see the leading coefficient is 1 or positive. Okay. So A is what we've been using for the leading coefficient. So we know that we have a fifth degree polynomial and A is greater than 0. So they kind of have the shape of the cubic in general. So it's that. So I know the limit here, the limit is of f of x as x goes to infinity is infinity, and the limit of f of x as x goes to negative infinity is negative infinity. So I can talk about those kind of things. So I should be able to quickly sketch a graph, which I agree here. I look at my two end behaviors, so I agree. And then we look at these zeros. We knew those zeros were there because we knew that x plus 2, when does that equal 0? X equals 2 at negative 2, which is that one. And we knew that x minus 1 had to be 0, so when x equals 1, that's the other 0. Now the question is, does the graph, since they're actually multiple, and we call this like the x plus 2 has a multiplicity of 3, so it has like 3 zeros at negative 2 and 2 zeros at negative 1. So what does the graph do? Well, you'll find out that multiplicity that we're talking about, if it's odd, in this case the x plus 2 to the third power, then the graph passes through the x-axis. The graph is through the x-axis. All right. So that's if we get an odd multiplicity. If we get an even multiplicity, that's what we see over here at 1, then we say that it does not pass through the axis. So if the multiplicity is even, the graph does not pass through the x-axis. So it will stay. If it's all positive values, it hits the 0, and then it'll stay all positive values. Go back up. Okay, let's look at another example. So here's my example. All right, quickly. I see a 2 and a 4 and no other x terms in here. So the degree of polynomial is 6. More importantly, it's even. And the leading coefficient, a, is greater than 0. So it's going to have the general shape of a quadratic. So here, my graphing calculator and my Desmos doesn't really help me, but I think this goes off for infinity in positive direction. And notice how I had to kind of zoom in, but I think the left part of this graph goes up to infinity. I don't know how high up in here, but I know in general the shape, the graph has got to go up and come back down. All right. And also analyzing, I know the zeros here. I know the zeros are x minus 3 equals 0, so x equals 3. So that one's right there. And x plus 5 had to be 0, so x had to be negative 5. That's that one. Now again, we look at this multiplicity of each 0. And that one's a 4, which is even. That one's a 2, which is even. So both of them, in both cases, the graph does not cross or go through the x-axis. So in both cases, the graph, it comes in and goes back out in the same in the opposite direction. Doesn't cross. Same thing here. I know that's coming down and then going back up. So they both. So I could have sketched that. I could apply the 3, -5. I knew what happened to my end behavior because they looked like quadratic. And then by looking at multiplicity, I know whether or not the graph crosses through the y-axis and comes back up, or crosses through the x-axis and goes back up, or if it actually crosses through.